I accidentally did save it as baby vectors. Oh well. Let's have a look. So, this lesson is so stupidly easy because we did this already in physics. So we'll just have a quick reminder anyways. This will be a good chance to reminder. So, what exactly is a vector?
It's a direction.
Yeah, it's a direction and a magnitude. But how can we represent this? We represent it
Arrow.
as an arrow. Again, you know all of this from physics, right? So here's our first vector. And we'll call this vector A. Right. So now, do you remember what we called this part and this part of the vector?
B.
No.
Starting at one point.
No. They have a name.
I have a name. Destination.
I know.
Shh. Jerry says he knows. Go ahead, Jerry. No. Put that down. You said you know. What's this called? Sean, you know?
Head.
I don't know. What is it?
And tail.
There we go.
Yeah.
Oh!
Head and tail.
Oh, yeah.
Yes?
No, I don't know.
What is that? Yeah.
The way it points is the direction.
Yeah.
And what's the magnitude? The length of it
One.
is the magnitude. Yeah? And this could be vector A. What? Did you wash your hair between the classes?
I took a shower and did a class.
Great.
Wow.
Great.
Wow.
Yes. And I see you're eating your breakfast too. Yeah.
I have to stay.
You're very strange.
I'm so hungry.
So I've got a student here who showers between classes and eats a box of cereal for breakfast. 2 students down, I've got so cool for school, I'm wearing my sunglasses. Then to your left I've got skateboard kid, fish boy, yeah, the only normal ones here are Chu, Sean, and Andrew. Oh yeah, vodka guy. Yeah, vodka guy. Yeah.
Can you roast that number to Sean?
Sean's normal. I don't think he does anything strange.
What do you want?
Earring boy.
Earring.
Earring boy.
I'm normal.
It's not happening in private too.
Do you know? I want at the end of the year a list of all the quotes from the classroom. So I want like a list of things that were said in class. So like today, Jerry said, "I'm normal, teacher." Or you know, like I want a list of what everybody says. Right. Let's see now. Those weird cracker things.
The red cracker.
Anyways, continuing. So, in physics, you might remember some things about vectors. So, what happens if you multiply a vector by a number? So, if that's A, then what's 2A?
2 times.
2 times the length, yeah. And a half A? All pretty straightforward, right? And what about minus A?
Another direction.
The opposite direction. Again, all fairly basic stuff. But what is maybe new for today is how do we add vectors together. So in physics we use something called, not quite,
Oh.
Result vector.
what? No, Jerry, no phone. What's the name of the rule in physics that allows us to add vectors?
Conservation.
Vector.
Conservation of vectors. Vectors can't be created or destroyed. Just change from one form to another. No, not conservation of vectors. Another law, please. Lee.
Result.
The triangle rule.
What?
No, because Pythagoras is only for right angles. So remember in physics, if you have a vector, now this is what we did in physics. If you have A and you have B, you're allowed to slide the B without changing its direction. So you could slide the B till it's here. Well, that's not quite right. I've changed the direction. I can see that. Thank you. Close enough. So if you want to add these together, you just put the tail up with the head, like this, and then the answer will be like this. That'll be A plus B. Now that's not Pythagoras because it's not necessarily right angle.
Teacher,
Yeah.
Monica said something stupid.
Go on, Monica. What did you say?
She said human centipede.
What?
Listen, don't take the opinion of somebody who wears sunglasses indoors, okay? What? Okay. Continue it. Now, this is how we add them in physics, but in maths, we have a different rule. It's nearly the same thing, but it's a little bit more involved. So let's have a look. So to begin with, it kind of looks like the same thing. If you have vector A and you want to add it with vector B, like this, what you do is instead of putting the tail with the head, what you do is you put the two tails together. If you want to add them. Okay, so the difference now is you put the two tails together in one common spot. Got that so far? Then what you do with a pencil or something is you draw a line, and this one must be parallel to B. So this one is parallel to B. And then here, oh, that's not right. This one here is parallel to A. And then the answer is where the two lines meet. This is A plus B. And this is the name of the lesson, not baby vectors. Parallelogram Law. How do we spell parallelogram? P-A-R-A-L-L-E-L-O-G-R-A-M-L-A-W. Parallelogram Law. That's what this is called. Can you draw this, please? This is the way to add them in maths. P-A-R-A-L-L. E-L.
E-L.
Sean,
Isn't it?
it's the name of the lesson on your worksheet.
Oh.
Look at Jerry's worksheet. It's the name of the lesson. Yeah. Yep.
Yes.
That's a rectangle.
It's that, yeah, actually, it's not a rectangle. Does anyone know the name of this shape?
I want parallel.
Yeah, I want to know that name.
Parallelogram. Yep, that's it. So just like in physics we have the triangular law, here we have the parallelogram law. What?
He asked that before, so
The name of the shape?
Yeah, it's right.
It's the name of the lesson. Parallelogram. Yeah, not quite rectangle, but yeah. Although there is a situation where it will be a rectangle, and that's if the A and the B are perpendicular. Then it will be a right angle rectangle. Okay, got that? Yeah, is there anything interesting on that page, or is it all baby stuff?
Or the machine 2a minus 2b times b.
Ah, but that's not. So you just multiplied 2a minus 2b. Yeah, you multiply the vectors by 2, and then you flip the other one around. So if this is a and this is b, then this is 2a, and then this is 2b, and then this is 2a, and then this is minus 2b, and if you want to add them together, and there it is there.
Oh yeah.
So that's the hard one, which is not too bad.
How about the 3
Yeah! So, if you have 3 vectors you want to add together, a plus b plus c, how do you think you can deal with 3 vectors?
You put like
Then add c.
Oh.
Well, I mean, that's not necessarily obvious. I mean, do we think that would be the same as this?
Yeah.
Why?
Because it's
But it's not plus in numbers, it's plus in vectors.
no.
Well, the answer is yes, but it's not because it's pluses. Just because you're adding doesn't mean you have all the same rules of adding. Do you know what I mean? But for vectors, the rules do hold true. For example, 2a vector plus a vector is a 3a vector. Okay? So the rules of adding still hold for vectors. But you have to be careful about these things in maths, because there are things in maths where the rules don't hold. So for example, Lee, there is no rule for dividing vectors. You know? And there is a rule for multiplying vectors, which we kind of did in physics. Using the right-hand rule is how you actually can multiply vectors. So, no, it's not. You were thinking, oh, I should have known this, but it's not obvious that this is the same thing as this, which is the same thing as a plus b plus c. And then you have to think, is that the same thing as a plus c plus b? Yeah, it is. But again, we shouldn't take it for granted. Yes, it is true, but we shouldn't take it for granted as a fact. Yep. So as you can see, this is all baby stuff, which is probably good because the last lesson was quite hard. So you should try these for a few minutes, but it's not really exciting. What's the next lesson? Is that any more interesting? Ah, yeah. Now it's getting interesting. Just look at it. Look at it. Yeah. Anyways, that's for next time. So if you could try these for a few minutes. Can I close this?